Welcome back, everybody. This is our week 4 geometry extension lesson video. It's going to be the first part. I'm going to break this up into a couple different parts here. So our first part today, we're going to be talking about what we call a sector of a circle. And I'll get to writing that down and explaining what that is in just a couple minutes. Before we start talking about sectors, though, we need to kind of go back and review some of the vocabulary that we've talked about before. So right now I have a circle. Right, we've got a center. I can call that C. Right, we call this circle C, and this circle C has a radius of R. We can put numbers there, but the radius, remember, again, is a spot from the center of the circle to the edge. That's an important value. Remember, we talked about radius. All right, so the R is going to be radius. We talked about diameter. Diameter would be the entire distance if I had another side here, right, of the radius. So this whole thing would be called the diameter from one edge to the other edge through the center. That's important. So this would be D for diameter. Diameter. And an important relationship between those two that we discussed before was that if you times the radius by 2, you're going to get the diameter, right? We have 2 radii, which would add to be 1 diameter. The important part that we need to cover today, though, is the area of a circle. So the area meaning all of the space inside. So we could shade the entire circle. And when we talk about the area, we're talking about all of the space that's inside of that circle. And so the area formula is pretty simple. The area of a circle, the formula is we take pi and multiply that by r squared. So the area of a circle formula is pi r squared. So area will equal pi r squared. So whatever r is, you square it, multiply it by pi. A lot of times we leave that in terms of pi, meaning that you're not going to actually plug pi into the calculator. You would just do r squared. So if our radius was 5, you would have 25 pi for your area. So depending on what that is. So again, if my radius is 5, then I would just plug that in. So the area would equal pi 5 squared, which would just be pi times 25. Or we usually rewrite that with the numerical value in front of pi. So 25 pi would be the area of the circle. 25 units squared, whatever the units happen to be. Remember, area is always units squared. The reason that's important is because we are talking about the area of a full circle, but the question becomes, what if we don't want to find the area of a full circle, but we just want to find a piece of the circle? And so that comes in, the area formula comes into play there. And also we know one other thing about circles that we kind of already know. The circle has 360 degrees, right? A full circle, if I were to start at one spot on the circle, go all the way around and end at that spot again, the full circle is 360 degrees. And that number is going to come into play here as well. So the next piece here is what we're going to call a sector. So sectors, what are they? So sectors are pieces of the circle, almost like thinking of like a piece of pizza. So a sector is definitely going to have something to do with the center and the radius. Okay, but it's very important that you understand that it's almost like a piece of pizza and it crosses through the center, or it includes the center. So if I were to create two radii, say one here, and again, I'm just going to call this the center C. So if I were to create a point, call this point A here, and point B over here, I've now created a sector, right? A piece of the graph, a piece of the circle, not the graph, piece of the circle. And so what we've done is we've created a sector, and it is made up of two radii, right? A to C is considered a radius, and B to C is also a radius. Why? Because they're from the center to the edge of the circle, center to the edge of the circle. A lot of you might remember from last week's video that this is also a central angle right here. I'm going to call this theta. Okay, it's the Greek letter theta. It represents the angle measure there. It can be in degrees. We're going to use degrees today. There's also another unit of measurement called radian that deals with circles. We're going to talk about everything in degrees today. So we have a central angle here that's created between these two radii. And this whole piece right here is what we call a sector. So the sector here from A to C to B. This is what we would define as a sector. Now, the thing that we can do with this is, what if I don't want to find the area of the whole circle, but just of the piece? How could I figure out how much space this sector is taking up? So what is the area of just that piece of the circle? So let's go through an example here. Let's talk about this. So the first thing we know is that an entire circle is 360 degrees, right? So if I were to start in the center and go all the way around and end back here, that would be 360 degrees from one to the other end of the circle, right? All the way around is 360. But in our sectors, we're starting somewhere, right? And we're ending just a small portion somewhere else. So how many degrees, right? How many degrees is this is kind of important for us. And the easiest way to kind of start breaking this down is to think about that first one. Maybe let's talk about an example with 90 degrees. Right? So if I had a circle, I know a circle is 360 degrees. But if I cut that into a quarter, right? A quarter of a circle here, I know that's going to be 90 degrees, right? If I know 90, because if we think about like our X and Y axis, right? Our X and Y axis, if I were to draw that in a circle, right? I have quadrant 1, 2, 3, 4. I know that these are 90 degrees each, and all the way around would give me 360 degrees. Okay, so this would be like a 90 degree sector right here. So if this is 90 degrees, the question becomes, how much of 360 is that? We kind of already discussed that. 90 degrees is really equal to one quarter. Sorry, drawing the wrong number there. 1/4 of the circle. Now, how can we show this mathematically? Well, 90 out of 360 degrees, right? This sector that I have in blue here, this sector right here, that angle measure that's inside of that is 90 of the total 360 degrees that are inside of that circle. So if I were to reduce this as a fraction, it becomes 1/4. This is important because we know that the area of a circle, we just talked about it, the full circle is 360 degrees. Full circle, 360 degrees, the area is pi r squared. We can kind of rewrite that as 360 over 360 times pi r squared. Now, these two equations are the same thing, because 360 degrees out of 360 degrees is just the number 1, right? This fraction reduces to the number 1, and 1 times anything doesn't change. So what we did here is we said, okay, the whole circle is 360 degrees. So I want the area of the whole circle out of the whole circle, 360 degrees. Sectors are pieces of circles. So depending on how many degrees your sector is, right, how many degrees, I want just that piece out of the whole circle, 360 degrees. So to find the area, I'll write the general formula here, and I'm going to use I'm going to use theta. So let me draw the circle again. So if we call the angle measure here theta, okay, I've kind of made it look like 90 degrees, but I'm going to call it theta. The area of a sector is as follows. I take that theta, whatever that degree is, that piece of the circle, divide it by 360, because that's the total degrees. So this is how many degrees that sector is over the total 360, and I multiply that by pi r squared. So again, pi r squared is the whole circle, and then we're multiplying it by a fraction, which means just a piece of the circle. So we have the area of the whole circle times the piece we want, and that gives us the area of the sector. Let's take a look at a couple examples. So we already kind of looked at the 90, but if I try that one more time, just to write out the full thing. Let's say I know that that's a 90-degree angle, and I'm trying to find the area of that space, the area of the sector. So the area of the sector, here's how I'm going to kind of notate it, A and then sector, equals 90 over 360 times pi. And I need to write a radius in here. So let's say the radius of this problem is 3. See if in our diagram it says the radius is 3. So I get pi times 3 squared. And then I just go through and I simplify this. I simplify 90 over 360, which we already know is 1 over 4, times pi. And I know 3 squared is 9. Remember that this is all multiplication, 1/4 times pi times 9. So the order doesn't really matter. I can do 1 over 4 times 9 times pi. And I'm going into the long version of this. You can simplify it pretty quickly. You can do 1/4 times 9, which is really 9 over 4, right? Multiply straight across, times pi. Or you can plug this in and get a decimal. 9 over 4 is 2.25. So we get 2.25 pi units squared. That would be the area of this sector. You don't have to simplify 9 over 4. You can leave it as 9 over 4. That's not a problem. And again, we tend to leave pi in our answer. It's a little bit easier, less rounded, more exact answer, and not a rounded solution. And then whatever our units are, squared. So if this was meters, it would be meters squared. Let's take a look at another example. So here's another sector. And again, we want to find the area. So let's say that the degree measure, let's say it is 195 degrees. So it's actually, this is not a great example. Sorry, wrong side. 195 degrees. It's over 180, so it's got to be the bigger side, right? So what if I wanted to find the area of this space over here? And the process is exactly the same. So the area of the sector is 195 over 360, right? So the degrees that we have divided by the whole circle, 360, times, and again, we're missing the radius. So let's say we have a radius of 5. Say our radius is 5 here. R equals 5. So that means times pi 5 squared. And then you just do some simplification. You could type this and this into your calculator. But again, remember, we just want to leave it. We want to leave pi in our answer. I'll simplify the long way for us one more time. 195 over 360. If you just simplify that fraction, is 13 over 24 times 5 squared is 25 times pi. And then 13 times 25, right? This is 25 over 1. So 13 times 25 is 325 over 24 pi. So you could use this. You could type that fraction in your calculator and get a decimal. Sorry, let me move that up for you there. I realize I cut my answer off. So you could use this as your final answer. You could type that fraction in your calculator and get a decimal and go from there. So these are sectors. The other piece that we're going to talk about in today's video are segments. So let's take a look at what those look like. So sectors are pieces of circles. Okay, sectors are a piece of a circle. Let me redraw that. So a sector is a piece of a circle, right? We have this whole space right here. That is what we would call a sector. A segment is even smaller. A segment becomes a piece of a sector. So a sector is a piece of a circle. And a segment, let me draw an example of that for you here. And we've got our sector. But what we're going to do is it's connected with a chord. So if I have these two radii, right, that create my sector, if I connect those two endpoints with a chord, it's called a chord because it doesn't go through the center of the circle. Remember that vocab from last week. So if I connect these two with a chord, the segment becomes this piece up here, right? So it becomes these pieces right here. Okay, so if it's a piece of a circle as a sector, then a segment is almost like a piece of a sector. So when you connect the two radii with a chord, right, we connected this dot to this dot, and now I want this space up here. All right. So this is what a segment is. This is what it looks like. And I'm going to go through and give you kind of a quick piece, a quick synopsis of how to find the area. Right? We know the area of the sector. We just talked about that earlier in the video. So the area of the sector is theta over 360 times pi r squared. Right? That gives us, this pi r squared is the area of the circle times the fraction that we want. That gives us the area of the sector. The area of the segment is very similar to this, right? Area of the segment. So basically what we did is we created this little arc here, this little space, the segment, and we created a triangle. This will always create a triangle with whatever degrees this is right here, theta. I don't know how big that is, but we create a triangle with one of these angles, and we actually created an isosceles triangle because these are both a radius. So we have two radii. We created an isosceles triangle here. So the area of the segment is equal to area of a sector, right? If I knew the whole space, and then what I'm going to get rid of is that triangle. So it's the area of the sector minus however big this triangle, the space inside of this triangle. So it's the area of the sector minus the area of the triangle that you created. That's the process here. What I'm going to do is kind of give you the formula that we're going to use here. We could go through and develop it, and I can help you out with that in our office hours if we want to talk about that in some more detail. But I'm going to give you kind of a condensed version of the formula. We already know this. We know the area of a triangle is half base times height. The problem here is that I don't necessarily know how tall that triangle is. So there are ways that we could break it down depending on how big the triangle is. But there is a general formula that's a little bit complicated, but we'll get some practice with it in just a minute as well. All right. So the area of the sector, I'm going to give you the formula here. So let me redraw it so that I can give you a general formula. Okay. So we're going to have a circle that has a segment with theta degrees in the center. I'm going to connect it with the chord. And what we're trying to find is how much space is there up here. So area of a segment. Area will equal. And what we're going to do is I'm going to kind of add some of these formulas together. So I'm going to take the area of a segment, or excuse me, area of a sector, and using kind of the some trig that we learned a couple weeks ago for the triangle, and kind of combine those into one formula. So the area of a segment is 1/2 r squared. Okay, so there's the r squared from here, times, in parentheses, theta over 180 pi minus sine of theta. This piece right here, the sine of theta, okay, that's going to be a little bit confusing as to where that comes from. And again, during our office hours, if you want to talk about how we develop that, I'll be happy to do that with you. Really, I want you to be able to have the formula, plug the numbers in, and practice using those as applications, maybe solving some stuff backwards. This comes from some triangle trig that we covered in a previous unit. The 1/2, if I were to multiply that through, right, this is like base and height. 1/2 here, 1/2 times 180 is 360. So that's where the 360 it kind of looks like it goes away, but it really didn't. The pi is here, and the r squared is here, right? And the theta is here. This is really helping us, the 1/2 sine of theta. This is with the law of sines. And so we're going to be, we kind of developed that previously, but we're going to just apply that into a problem. So let's practice one. Let's just see what that might look like. So let's say we have our segment here. And again, I'm trying to find the area of this space. This is the segment right here. I'm trying to find the area of that space. Let's say our degrees here are 60 degrees. All right, so I'm just going to plug these numbers into my formula, and our radius here is 4. We have a radius of 4. I'm just going to plug these numbers into our formula. We've got a equals 1/2 4 squared times in parentheses. So theta is now my degrees, which is 60 over 180 times pi minus the sine of 60 degrees in parentheses there. Okay, we can start to simplify this in this information here. So we're going to have 1/2 of 16, right? And then in parentheses, 60 over 180. We can simplify that to 1/3 pi minus, and in here we're going to get kind of a approximate answer. We're probably going to put pi into our equation, into our calculator here. So, and then we've got the sine of 60, which is, again, we're going to get decimals. You're going to just round. That's about 0.866. Start to do some of this math. So we're going to do 1/3 times, we're just going to use 3.14 for pi for those of you that are trying to do some math on your phones maybe. Okay, and you can turn it sideways, usually get the pi symbol. But 1/2 of 16 is 8. 1/3 of pi is about 1.05 minus 0.866. And then type all this into a calculator. 8, and you get about 1.472 units squared. So the calculation part, you can go through and do in a calculator. It'll help you out a little bit there. We're going to plug pi in for those pieces, and just apply the formula. So there's what a sector is, what a segment is, what the difference, how to find the area of both of those. And for our part 2 of our video, we're going to talk about tangent lines. I'm going to break that up into a second video for us here. So check part 2 out. That's coming up just after this.